kind of high-tech progress was amazing in the past, from the 80s, over 30 years. Even the kind of the CPU, the processor of computers for us, we live on that. Now it's more and more on our mobile phone, but in our office, we know in our both mobile phones are getting from dummy to smartphone, and our PCs. We remember before the processor named as Pentiums. Today, I don't know how to call the processor anymore. We don't pay attention to that. It's fast enough. I remember when I did my early simulation when I was a graduate student working as RA. I had to use our department 286 computer. Calculating a simulation problem may take me a whole night. I used to work day and night. Daytime is study, nighttime work on computers for simulation. It was a very different world when we think back how life was in the 80s. Computers were very slow, no internet. When I sent my PhD thesis to my supervisor, Steve Williamson, when he was a head of department at Iowa University in the early 90s, I had to use post. I had to go to a post office on campus, and going there, coming back may take over a month. Unlike today, we can attach. Submission to journals today is also very different. While the high-tech time, the tech boom decades, the 7 rates declined so much. The US post-war data also indicated a positive correlation between R&D expenditure and GDP, but a negative one between GDP and private saving in terms of net private saving. There are models today we call growth cycle models with endogenous growth, endogenous cycles. So extending from endogenous growth models in the 80s, now in the past 2 decades, we have endogenous growth as well as endogenous cycles. Even though some of them still use shocks, aggregate shocks to create cycles and check the responses of R&D and saving, but there are some models without aggregate shocks managing to still get cycles. Typically, growth models using production factors, capital or labor as R&D inputs that get into predictions about counter-cyclical R&D because factor prices are relatively high during good times in terms of booming economy. Those using R&D, using final goods for R&D, especially with shocks that predict pro-cyclical R&D as well as pro-cyclical saving. We remember in those macro models, usually saving is just household saving. In most of the models, they're just a household sector saving for investment, right? Yeah, we also have models using labor as R&D inputs, managing to predict pro-cyclical R&D. However, it has to assume delays in implementation. When R&D comes out with implementable ideas, firms may hold on, and with delays, when we have delays, timing becomes the kind of a trick. So that is a different approach. Here we have the data in the US from 1959 to 5 years ago. On the top, it's total R&D expenditure, federally funded or non-federally funded alike. That fluctuates in medium frequencies. Medium frequencies usually refers to a few years, even a decade. So in the 50s, we know it's a Cold War time, right? We have the kind of government federal expenditure on H-bombs, on missiles, centralized going to the moon. That's the 50s, 60s, the government expenditure. At that time, relatively, this line is a private, non-federally funded R&D. So that was used to be very much low compared to total. The gap between here and there would be the federal expenditure. They used to be high, but gradually declined. So after the Cold War was ended, we can see non-federally funded R&D becomes the major component. And also with declines and increases at medium frequencies, that's R&D feature. They have to plan, they have to experiment. R&D refers to here like lab, researchers combination, right? They have to be there. Every year we have a Nobel Prize announcement for work that may take the researchers over 10 years. And at the bottom is growth rates. We have left, right scanning. The growth rates used to be fluctuating at high frequencies, and at the R&D, when the private sector R&D goes up, we can see we could have over 10 years consecutive quarterly, quarter-to-quarter growth, and even though there are also downfalls. So the growth rates fluctuate not as frequent as in the past, in the 50s or in the 60s. So it's more persistent. The autocorrelation in time series shows a change in pattern. Those two lines are private saving and household saving in percentage, scaled on the left. You can see the decline at the tech-boom time when R&D goes up. Household saving, private saving actually declined until the Great Recession. The Great Recession made a turning point for net private saving. Okay, so that's what this paper tried to match with endogenous cycle growth models without shocks, try to capture the co-movements and the volatility, the standard deviation of based on those. The calculation here based on the figure is given here. We have the three types of popular filters to detrained, and column 1 labeled here are standard deviations. And column 2 here are co-movements, the correlation with GDP. We can see the GDP volatility is about around 2 units of standard deviation, and R&D is between 3 and 9 and 4. Private saving and personal saving, household saving is over 10. So the most volatile components of expenditure would be private saving and household saving, followed by business-funded R&D. Here is all business or non-federal funded R&D of the similar scale in terms of volatility. There are co-movements. R&D have a positive co-movement with GDP, but personal saving and net private saving have negative one. Across those three types of popular filters.
Can I interrupt briefly? Is it possible to go back to the previous graph a moment? When it seems to me that you're leaving off an important time series here, and that's the total value of assets, right? So that is total wealth. If this is the United States, where those saving rates are going down, wealth in the US is going up. And this is, and so those low saving rates out of disposable income are just a reflection of a wealth effect. As really, I mean, for much of this period, the whole world's saving is being directed into the US, pushing up asset prices, including housing prices, except for, you know, the one or two glitches that occur. So the decline in saving, and you're not going to explain that properly unless you actually have the wealth story in there, I think.
Yeah, thank you for your point. We did not pay attention to the total asset side. Yeah, I will think about that.
Yeah, well, just in terms of information, I mean, if you take a look at GDP growth, as you show, sort of 2-ish% throughout this whole period, but from the early 1980s onwards in the United States, the purchasing power of private wealth over goods rises at about 9% per year. And this is in part associated with the big concentration of income and wealth in the US that occurred during this period. But I think it's, if savings to play an important role in your story here, then wealth probably should also.
Yeah, we require UniSuper and home values in Australia. Yeah, it's associated with the extension of this study. We planned but have not done yet, is to have the kind of nominal variables, monetary phenomenon, trying to, since the 1980s, we know the Fed rate policy changed in direction, relatively low federal rates, right? So the kind of reduced risk-free returns that helped increase the asset value, asset price.
Correct.
Okay.
Correct.
Yeah, it's a motivation part for the next stage. But here it's like a real business cycle model without shocks. It's all in those. When we talk about asset, we have to come with the Fed policy, with money, with bonds, with those kind of things, associating those with also homes, right? Yeah, those retirement funds. There are lots of institutions in society that are important for better understanding. Okay, thanks.
Yeah.
There are lots of studies about possible causes for the decline in household saving rates, including capital gains, goes into the wealth issue, and public deficit or debt, that inducing central governments to keep low rates of interest to roll over public debt. They have no choice. They have to manage the government burden. the tax revenue cannot mostly used to repay accumulated debts. And the medical cost. In the US, we know medical cost increased quickly from the 80s. Used to be roughly of the similar scale as the Australian level, but from the 80s, the US medical cost goes up. Okay, however, that literature has not linked the decline in saving to R&D. So that's the kind of missing dimension we try to do this work as part of the motivation. Yeah, the purpose of this study, I should also mention that there are empirical studies finding procyclical R&D in US data and some OECD countries data. The OECD countries data are relatively detailed about saving, investment, and GDP, but not much about R&D or R&D related policy until recent, say 2 or 3 decades. Some countries come later, some countries earlier. It's the kind of difficulty for researchers in this line to get GDP R&D data. The purpose here is to find the kind of empirical evidence with updated data and also try to explain those in the endogenous growth cycle model. Yeah, empirically, we use 15 OECD countries data in nearly 17, 18 years since year 2000. The data limitation couldn't go back earlier. Yeah, the common method in the literature for this type of cross-country macro data regression is a reduced form. We try to use a 2-stage structural estimation and try to find instrumental variables for decision variables like R&D, saving, those critical variables. Yeah, try to have a causal relation from this investigation. So that suggests R&D and total saving, gross saving, have positive causal impacts on GDP growth. Yeah, when gross saving investment are controlled, private saving and GDP and growth rates have negative correlation. We also come to this model. We also estimate in fixed effects estimation of the R&D equation, saving equation. We find a negative effect of R&D subsidy and income taxes on household saving rates. That's critical for our study. We argue that this is the key to allow the model to generate procyclical R&D. We start from a model without public finance, then it's countercyclical R&D. We use this to turn the story around. And confirming the literature's finding that R&D subsidies have a positive effect on R&D by reducing R&D cost. That is intuitive. It's found in the literature. The opposite effects of R&D subsidies and income taxes suggest that they have destabilizing impacts. They have different impacts on R&D versus capital accumulation. For balanced growth, we need investment in capital and R&D to grow proportionately due to the different impacts of public policy that turn to set them apart, encouraging one, discouraging the other. So this actually destabilizes the economy. That's the suggestion from the empirical study. That's why we try to do that. We try to come with some confidence. Yeah, the model makes sense. Theoretically, we will do in two stages. We start with a model, the Matsuyama's model in econometrica in 1999, and later version in JET 2 years later. Yeah, that model has a counter-cyclical R&D and fixed saving rates or pro-cyclical saving rates. We try to explain the observed cyclical properties, the correlations, standard deviations, match this in data. Okay. Now, why we pick up this model to begin with? We try to see how public policy can turn the story around. That's one motivation. On the other hand, we know other models, the Matsuyama's model uses CAMTO like lab equipment R&D based on the earlier model of Rivera, Battis, and Romer in 1991. Other models that either use final goods or labor as R&D inputs. We know when those things are used, we will get balanced growth at all times. The famous paper we have, Zhang and Howitt in econometrica, and more recent papers. Going with that approach, we get into balanced growth at all times without shocks, unless one introduces aggregate shocks. Many of those studies in this literature use aggregate shocks to initiate the disturbances and look at how R&D responds. They didn't pay much attention to private saving. They used household saving, but they did not name it as household saving. In data, we know the difference. When we come with household saving, actually it's negatively correlated with GDP. The Matsuyama's model has fluctuations unless the saving rate is very high for fast counter accumulation. It has counter-cyclical R&D with a constant saving rate. The reasons are given here. One is the constant saving rate. The other is monopoly pricing that creates a loss in output, the efficiency loss, reducing demand for newly invented intermediates. So that's the kind of monopoly pricing story. And also distinct from other models, it follows the neoclassical assumption that we need CAMTO in place in order to make resources available for final goods production. Final goods production need intermediates. Intermediates are based on converted from available CAMTO saved from the past. And R&D has a fixed cost in terms of CAMTO. So this follows the kind of Soros idea back over half a century ago. It's a combination of Romer and Solow in that sense. Those two models in combination. It's a very simple, smart combination, allowing that paper to go into econometrica. Okay. In that model, when we have R&D and a fixed cost, there will be a break-even level for R&D, break-even level of demand. That in this model, intermediate goods depend on the level of capital available. So that converts into a break-even level of capital per variety of product of intermediate. The break-even level of capital per variety or per intermediate is the key variables in the Matsuyama's model. So when R&D occurs, it creates new varieties, at the same time reduces available capital for available intermediates. It has offsetting impacts on output at the time with active R&D. So whenever R&D occurs, the change in output is outpaced by variety expansion. So in other words, capital per variety must decline for the next period. So when capital per variety falls below the break-even level, what happens is that there would be no R&D and all resources are used in production. Going back to the Soros model. In that model, we know when labor is fixed, there is no R&D for new varieties, then the ratio of capital to the number of intermediates will go up. That's the Solo story. It goes between Ramer and Solo in this fashion. So there would be cycles possible, especially when the household saving rate is not high enough. There will be indefinite fluctuations. Counter-cyclical property comes out with, in one way, it's monopoly pricing. When R&D occurs, monopoly pricing creates differences in the level of intermediates, old versus new intermediates. We know intermediates, by assumption here, are symmetric. If you differentiate their level, then their marginal contribution to output will be differentiated as a consequence. So that means a loss in output, a static as well as a dynamic loss. Here we pay attention to the static loss that gives to the counter-cyclical R&D.
Yeah, can I seek clarification on this? I mean, is the bit that I'm having trouble with is normally we think of R&D as investment in the supply of information. Now you're thinking about R&D as investment by firms in the construction of new varieties. Right? So it's like it's an investment in a production process of new varieties.
Yeah, that's there are two ways usually people approach the kind of R&D outcome. Yeah, one is creating varieties, new ones. The other way is improving quality.
Yeah.
The Armstrong Howard story in econometrics is in the quality ladder. R&D improves the efficiency, quality of fixed number of products. Yeah, there are two versions of that. We also tried to have both.
Yeah.
Quality improvements combined with the kind of new types of intermediates. Yeah. But the model would be very messy. the kind of subscripts and superscripts, the kind of, you have to indicate also quality. That does not impact on the results in the paper, but it improves in one way. Here, R&D is go and stop. In reality, R&D never stops. When we have quality improvements and a new type creation, then it's like R&D never stops.
Yeah.
So that has importance in understanding the data. The data has ups and downs for R&D expenditure.
Yeah.
Okay.
Yeah, so in some sense, you're thinking about fluctuation between the extensive margin and the intensive margin on the role of R&D.
Yeah, that's the key.
That's where your fluctuation's coming from. I'm wondering why a vintage capital model isn't used here, in the sense that new capital embodies the results of R&D. Therefore, new capital is going to perform better than old capital. Whether or not a model like that. The same thing.
In the statement of Matsuyama himself, capital here includes human capital as well. So physical and human capital. He broadened the notion of that from the kind of Soros model to include the kind of human capital, especially for simulation.
Okay, thanks.
Okay. So extension from the Matsuyama's model to have taxes and subsidies are also available in the literature, either R&D subsidies financed by lump sum taxes or consumption taxes. In those papers, the policy would promote R&D and growth intuitively, however, maintain countercyclical R&D. They use log utility function, get into the kind of constant saving rate. So the maintain countercyclical R&D and stabilize balanced growth when subsidy rates are high enough. So eventually, when you subsidize R&D at higher and higher rate, eventually it's back to the Romer's model. There is no cycle, the contribution from those. The departure from those extension is that we use income taxes to finance R&D subsidy. Then, like in those models, subsidizing R&D increases R&D spending. That is good news for growth. So we know in those production functions, when we use the symmetrical property of intermediates to rewrite the production function, actually GDP is proportional to the number of the types of intermediates that have a proportional relationship. When currently R&D is increased by R&D subsidy, that has a proportional impact, positive on output. However, the R&D subsidies payment will increase household income outside the normal notion of output. It's subsidized outside the production sector. It's in the R&D sector. So capital income includes R&D subsidy payment. When we have income taxes, income tax burden also goes up. That will increase consumption relative to output. In other words, increase saving, but not as much as increasing household income. The saving rate, household saving rate would come down. So the R&D subsidy financed by income taxes will have negative impact on household savings. That is bad news for growth, not in this period, but in the next period. In the next period, there will be not as much capital available because of income tax financing R&D. Subsidizing R&D is fine, but if we use income taxes to do so, yeah, it's a different story. The income tax also reduces the expected return, anticipated return of saving as well, because it will be taxed. So those factors, income effect, substitution effect, that goes back to those basic elements of intuitions, the toolbox we can come up easily. So when R&D subsidies and income tax rates are high, output growth rates are high, but saving rates are low at times of with active R&D compared to times without active R&D. That comes, in other words, with pro-cyclical R&D, but counter-cyclical household saving. Those different impacts on R&D and saving destabilize the economy. The balanced growth path requires proportionate increase in innovation for something new and a saving for capital accumulation. The different impacts from policy actually destabilize this balanced path. As a consequence, we will not, when we increase R&D subsidies and taxes, we will not stabilize the economy. Actually, it goes for new patterns of cycles. We could get unstable period 4 cycles. Matsuyama concentrated on period 2 cycles. Go, stop, R&D. But here is R&D can go, and stop. We could have consecutive, typically P4 cycles are 3 periods R&D followed by 1 period without it. That's very much like what we have in the past 3 decades. We could have over a decade of consecutive growth and a sudden stop, bad times. Okay, we could even have P4 cycles. Yeah, when we encourage R&D so much, that requires 2 periods of saving without R&D to make up enough capital per variety yet for R&D to come back again. That's new. In the literature, it's ruled out in this literature. Matsuyama had a note ruling out these P3 cycles. Yeah, those 2 are called chaotic cycles. The unstable cycle is what we want to have. We want to see whether the plausible rate of taxes and subsidies give us the kind of unstable cycles. Unstable cycles is hard to discern from random factor-driven cycles that behave in a similar way. So that creates the kind of scenarios for competing stories, endogenous cycles versus shock-driven cycles. Okay, so those are the kind of results we get from the baseline model. The shortcoming of the baseline model is that when we have constant, when we have the kind of full depreciation, those things, the relative degree of volatility of private 7 is much lower than the kind of compared to output, lower than what we observe. We need to extend the model to have partial depreciation, like 10% per year. That will strengthen the contribution of 7 to future capital accumulation and R&D. Increases the persistence of GDP growth or R&D. We also will bring in R&D labor. Labor is now allocated between R&D and production. When we have R&D labor division between production R&D labor, then it could be counter-cyclical. That will weaken the correlation between R&D, still pro-cyclical, but not as tight as before. When we do things like that, then the calibration results at extended model. It has no reduced form analytical solution, but we can determine the path implicitly and solve it numerically. That will allow us to create unstable cycles to reproduce the story we said at the beginning, that for the decades of R&D, the high-tech time, we have declined low 7 rates. And we can match the moments, first and second moments, the correlation, co-movements, and volatility. We also experiment with income tax cut. When President Trump came to office 4 years ago, we remember that. That will increase average saving and growth. However, bad news for R&D by increasing the cost of R&D labor. When tax cut increase labor cost, the wage goes up. So that's bad news for R&D. And reduce volatility in this model. We know the basic model story says when policy income taxes have negative impact on saving and positive impact through R&D subsidies on R&D, that destabilize the economy. When we come backwards, not an income tax increase, now it's a cut. Actually, it reduces volatility. It's moving towards balanced growth, not reach it, but in a direction going to that. I only have about 10 plus minutes, so we can briefly look at what we did in the model without going into details. So here we have the conventional approach estimation, least square, the kind of reduced form dummy variable estimation used in the literature, and a two-stage least square in our case. This is what we did from the new data set we come up. The data set has 15 countries from year 2000 to 2017. We can say that the regression is dependent variable is growth rate. R&D GDP ratio has positive impacts on causal impacts. We have an over-identification test and past identification test restriction, those tests. So we did that. we interpret this two-stage least square prediction as a causal effect. Positive one from under the GDP ratio. However, we have total saving rate and total investment GDP ratios here. Whether those two are positive or significant depends on where they are. When we control those in the conventional approach, people claim investment has a positive causal impact on GDP. It's true, but not here. Here is gross saving. So we can say actually the difference here says this is Solo, this is Romer, right? The Romer says the 7 contributes because total 7 means also the high 7 means high investment for R&D with a time lag. So all the variables are averaged over 5 years. That's a moving average. We try to make as much use of information. It's not annually observation, it's a moving average, fitting our notion of midterm cycle over a few years moving average. That's what happened in the literature as well. Using moving average, trying to filter out quarterly disturbances, high frequency disturbances, focus on midterm ones. When we control total investment, total saving, then household saving here is negatively correlated with GDP growth.
Can I interrupt there just for clarification? On the measures you're using, so the gross saving rate, is that simply from the macroeconomic data, that Y equals C plus T plus S, so we calculate S? That's private saving, sorry?
Yeah, it says reported on national accounts from those countries.
Right, so, and so that does not include government saving, is that correct?
This is everything.
So it does include government saving.
Yeah, so, government surplus, deficit, trade surplus, those kind of the kind of open economy, the online accessible gross saving rates, like from IMF, from those places, the come out with the total. We know the model is a closed economy model. We use this gross saving to say that can also allow us to say the difference between saving and investment.
I'm not sure what you mean there, but because whether you mean that saving by foreigners that purchases capital goods in the home economy is also classified as saving, or whether you just mean that we're talking about the total domestic marshalling of resources to finance investment. But one of the interesting things, when you look at these numbers, in your first column, the gross saving rate and investment seem to have about the same effects, which is something I would have anticipated. But when you move to two-stage least squares, you see that there is now a huge difference between the effect of gross saving and investment, right? So a tenfold change in the effect of gross saving. How do you explain that?
Since the model is a closed economy model, data comes out with open economy setup. The gross saving has components, especially from the government. It's like a government deficit. In most of those countries, there is no government surplus. Right. All the 15 countries have various degrees of high. It's about around 3% of GDP annual government deficits. Mm-hmm. So that goes into the gross saving not captured. In our model, we follow balanced budget approach in a closed economy. So that is not easily understood here. Also, like investment, domestic investment, so investment is more like domestically recorded. Saving includes trade surpluses or deficit. Yeah, it's in the open economy, there are open economy issues there, especially big countries like those 15 countries, European unions that have free borders for trade. And outside that, Japan, US, and China, that are also close trade partners that have big amounts of trade surplus and deficits that go into the gross saving. That requires a broad model for good understanding why the story between saving and investment can be so different.
Yeah.
I have no really story to tell the whole thing.
Okay.
Yeah. So what we pay attention to is those first two. The other two are not in our model, even though we have variables corresponding to them, but differs from them. We use a closed economy model. We also run reduced form fixed effects estimations. We have equation for R&D ratio, GDP ratio, household saving ratio, and we have taxes and subsidies. So R&D subsidies have positive impacts on R&D expenditure, but negative impacts on household saving. Labor income taxes or uniform household, the personal income taxes, that have negative impacts on household saving. So that's the kind of results for the model. There is no time to introduce the model. We look at just the diagrams, the Matsuyama's model P2 cycles. We have the break-even level of capital per variety. On the left half of this line, it's the solo model. The ratio we denote by K, capital over number of intermediates, has a positive slope before reaching the break-even level. That means in this part of the diagram, there is no R&D. This ratio goes up. Beyond this break-even level, R&D occurs, and this ratio comes down, as we earlier explained. Because R&D uses capital, reduces capital for intermediates, in turn for production, as well as monopoly pricing. Those factors explain the downward sloping of that. This corresponds to a subsidy rate on R&D 20%. The US effective subsidy on R&D is about 30%. We hold in all those figures, that's based on simulation, not illustration. That's from numerical simulation. We have income tax rates 24, average income tax rates 24%. Here we have unstable cycles. The unstable cycles is different. For the two period cycles, if we start here with R&D, then go to the 45-degree line, up to the solo equilibrium without R&D, and to the 45-degree line for reflection again, then back to here. It's a stable P2 cycle. It holds, fluctuates forever. If you start from here, quickly it comes into those 2 points. So the trapping region would be somewhere on those 2. The economy fluctuates always in this region. Okay. When we have P2, P4 cycle, then when you start from here, 45-degree line, solo, and 45-degree line, and Ramer, and 45-degree line up, Ramer again, and 45-degree line back, Ramer. So it's a 3 period Ramer versus 1 period of solo. It's like 80s PC, 90s internet, and followed by smartphones, right? And make 3 leaps and sitting down. Because when 7 goes down, 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 eventually bubble, right? That's the kind of predicted Great Recession. Predicted not by all, by some. So a great advance of this model is endogenous cycles is useful for macro because you can tell fundamentals to understand the economy, make smart investment. So the kind of famous investment people that are successful not because they're lucky always, because they're smart. They make use of information, they understand internal laws, relations governing the process. When I was a macro student in the late 80s, I was taught by real business cycle big guys, and I feel sorry for them. As a macro guy, if someone asks me, how do you predict the future? I say it's just depending on whether we're lucky or unlucky tomorrow. That's kind of learned nothing from macro. If you ask what we should do in reaction to those shock created cycle, answer is free economy, nothing we should do. Even a social planner would do the same thing, betting on good luck or bad luck, right? There is no input to society from this kind of macro. It serves to preserve the free market economy with respect to that. Here is not a destruction of the economy. Here comes with a remedy, what government can do. So we have P3 cycles. Here, 45-degree line, solo, 45-degree line, solo, and back. So one big R&D followed by that used up much of the capital stock. It's like prior to the critical Great Recession. When capital was used up, what's up? What's up would be a downfall. We have pro-cyclical R&D. When R&D was there, so was growth. It's booming. When R&D is missing, then it's a recession. We can create a recession if we scale down total production factor. So this is the kind of bifurcation diagram. We can see P2 cycles up to subsidy rates 28, 27%, then P4 cycles unstable P4 cycles. It's interesting. The P4 cycles allows us to travel everywhere in this region. It's continuous nearly, and followed by a discrete P3 cycle that requires very high, above the US level. The US level is somewhere here. In terms of welfare, welfare is highest around the US level subsidy. So that's the story we try to make. So we have propositions here to make it more formal, but the final thing would be the simulation, the benchmark simulation, standard deviation and the correlation. Output standard deviation around 2 as observed. And R&D, it's between 3 and 4. Household saving between 11 and 15, slightly above it sometimes, depending on which filter we use. Correlation negative, household saving here stands for saving used here. R&D positive correlation. So we actually match the size of co-movements and degree of volatility. The literature pays attention to this volatility and the sign of the co-movement of R&D without saying much about household saving rates. So that's, we also have tax cut story. I know my time is limited, and that's a 5 past 1. I should stop allowing for questions.
Great, thanks so much, Zai. Thanks very much for an interesting presentation. So we have 10 minutes for questions. Maybe if I can kick us off. I'm not a macroeconomist by any stretch, but I'm interested in the relationship between R&D and savings, and you find a negative causal effect. And I'm interested to know whether or not you can find data that's disaggregated by sector in terms of R&D, because I mean, what we know is, and one of the theories that you propose for the decline in household savings is the rise in medical expenditures. And what we've seen in the US in particular is a massive increase in health expenditures over time that's attributed to, well, people attribute to medical innovation and to particular medical technology. So it seems to me there's a potential pathway from R&D to household savings through the medical sector, but I don't know whether you have that sort of data. I think it would be potentially interesting to explore.
Yeah, at the same time, I'm also working on a paper about household saving and health investment. It's in that model, we have shocks. It's like the pandemic. We have shocks there, we have medical technology, we have production. We try to have the mean and the standard deviation of those technology total factor productivity to determine factor return, the risky returns. We have safe technology, risky technology. We try to make use of information from the stock markets. We can measure the mean and the standard deviation of returns using stock indexes, country by country. Since we have macro data, how to make use of macro data, in doing that require us to do pricing. The pricing of those are risky, we have 2 sectors, right? We have to actually do the kind of determination of risky prices. We combine learning by doing with aggregate shocks. So in a way, we can use the mean and the standard deviation observed those kind of stock markets to try to determine unobserved random technology, total factor productivity.
Oh, very interesting.
Sorry, Michael,
After you, Rodney.
can I complement your question a bit? I mean, while it's what you say is true about the cost of medical services and so forth, and that's not only true in the United States. Another fact, related fact, is that government expenditure on new infrastructure since the early 1980s in all the OECD countries has moved toward increased proportions spent on health and health-related matters. And the same is true for R&D. So R&D expenditure has increasingly been directed to health. One of the consequences of that is that there is an increase in life expectancy beyond 60. That is that people are living longer, but the major effect on their productivity is occurring after they retire. And so so what this means is that the health-oriented R&D has a very low total factor productivity payoff, because what it's doing is elongating people's lives, improving their welfare, of course, but not increasing GDP. And this, I think, is an important thing to capture when you're thinking about these things. I mean, it's
we did that in the paper I just mentioned. We also have growth equation in our regression. The other paper also goes in theory and in regression, in estimation.
Right.
When we compare across countries, we have a bigger sample. 85 countries, we divided them into countries with old versus young population. So by initial old age dependency, as well as by income, rich versus other countries. So in those countries, we can see if we have a high initial old age dependency, that has negative impacts on life expectancy. In that model, lifetime is a choice at the cost of medical expenditure. So in that model, actually, the population aging used to be understood as having negative impacts on the economy. Population aging in terms of already so many retired people. It's a economy-wide phenomenon, not anticipated longer life. It's just already with old population high, like in Japan, in Australia, what's the consequence? That's population aging worry in 20 years ago. So that usually goes, now more resources going to healthcare. In that model, we have public healthcare for retired people. That's true in the US, right? In Australia, when people run out of resources, then the public healthcare takes care of them, right? When we are university professors, we have to buy insurance. But when we retired, initially a few years, maybe our income is quite nice, but eventually it goes thinner and thinner. We turn on public healthcare support. We have that there. That's the mechanism to reduce current generation's choice, the competition for resources, right? Shorten their planned lifetime. So that's found in data. In terms of growth, impacts on growth, population aging, we found the opposite. Because population aging reduces planned lifetimes, actually population growth goes slower. That's good news for growth. In that model, we have the mean of risky returns, population growth, 70s as growth determinants. in that kind of model.
Can I suggest one other thing, and that is when you're talking about gross saving, an important element of it is corporate saving. And
corporate saving, especially we checked in data, very much it's a capital depreciation. Our extended model has a sensitivity analysis. We divide saving, private saving into corporate saving and household saving. Household saving exclude depreciation replacement. So replacement investment goes into corporate saving. Corporate holds intermediate goods, partly the depreciate, right? That's corporate responsibility for that. When we, you can say when we move out that, the net private saving supposedly excluded depreciations replacement, we can say it's still negatively correlated with GDP.
Okay, I mean, it is, I mean, the trend, to the extent that your analysis depends on trends through time, and you've got these trends in household saving over time, what we have is an associated trend in interest rates, which is downward, and which has had a tendency to discourage private saving, but it's also had a tendency to mean that dividends can be smaller and still competitive, which means that firms retain more earnings, which means that corporate savings actually rising through time. That is, over time, you don't have a stable relationship between the household saving component and the corporate saving component. But it sounds like you've actually disaggregated and you've looked at the differences in those behaviors when you're constructing your saving variable. I was simply suggesting that you do that because the behavior of corporate saving has been inclined to increase. It's been very high in East Asia, as you know, in China. It could be, 20% of GDP corporate saving. And so the effect of corporate saving, which behaves differently from household saving, perhaps needs to be treated differently. Sorry. No, finished.
Yeah, in our sensitivity analysis, as I mentioned, we have final sectors under the improving quality of final goods. We use that to be financed by firm saving, that's corporate saving. We were aware of this, so we had a corporate saving beside depreciation replacement, but also have quality improvement R&D. When we do that, for that component, the corporate saving would be going to pro-cyclical. Household saving would be counter-cyclical. Yeah, we try to use that since that model is very messy. No journal would like a model with so messy expressions. So we thought about it again and again, whether we go into that detail. When we try to decompose, we say we go for simple ones first. Yeah, if they buy it, then we can go harder, right? Otherwise, there's nothing in the end.
Yeah. Okay. Good luck with the journals buying it.
Okay. Yeah. Thank you.
I think we're running out of time, unfortunately. Does anyone have any burning questions? Perhaps time for one more short question.
Yes, I think it's a matter of time. I have to raise my hand there, and Roland doesn't follow the rules. It's okay. I'll answer next time. Thank you.
Okay, well, great. Well, thanks, everyone. Please join me in thanking Professor Jie from NUS for a really interesting presentation. And hopefully we can see you in Perth at some point in the future when your teaching load gets a bit lighter. So
I
thanks.
will finish NUS this year and free to move.
Oh, fantastic.
Yeah, so
We-
that's
we-
the pandemic stops Aussie citizens from coming home. I still have my home renewing my lease, my home in Brisbane.
Ah, very nice.
I renew it 1 year